Hello class. This video we're going to talk a little bit about strings. Now that we're getting into loops and conditional statements, things that require comparisons and Boolean expressions, strings need to be handled a little bit differently. So we've been looking at a lot of primitive data types such as numbers and integers and floats and characters and such. Strings are objects. So what an object is a collection of data and operations, or data and methods, that can be used together on a single object. So if a string is an object, it has data. That data would be the value of the string itself, whatever the text is. And then we have the different operations. And we've seen some operations, and we're going to take a look at a bunch of more now to see how we can use them to compare strings and parts of strings so we can help process code better. So when we think of comparing strings, visually you can consider this as comparing strings alphabetically. For example, the textbook likes to use the apples and oranges comparison. So if we thought about the word apples and the word oranges, clearly those two words are not equal. And if you think about how they would appear in a dictionary, apples would occur before oranges. The A would become earlier than the O. So let's take a look at some code and see how we can use some of the string comparison methods that are built into Java to help us determine equality or inequality and which one would come first or after another string. So we'll jump over back into our lab, test lab, and we'll create some strings. We'll create string 1. We'll call that apples. And remember, strings get double quotes. And we'll call a second string, string 2 equals oranges. So we have these two strings. If we wanted to do a comparison, if string 1, not capital S, string 1 greater than string 2, we can print out, we'll just do a simple print string 1. If string 1 is bigger, we'll print string 1, else we'll print string 2. And let's run it and see what we get. It sure does not like that. Does not like using the standard relational operators that we've been using for primary types. So we can't use those. We need to use special methods that have been built into the string class that will help us do these comparisons. So before we go implement this new method, let's take a look at the textbook and see how it works. So if we come down to the string comparison section, and we're going to jump around a little bit here. We'll try to cover it all, but we're going to jump around a little bit. This is the table I want you to look at. This is where we compare two strings. You have the string that you start with and the string you want to compare it to. And we use the method compare to. And you get three possible values back: a positive number, a negative number, or 0. Negative number indicates string 1 is less than string 2. Positive number indicates string 1 is greater than string 2. And if you get a 0 back, that means they're equal. So we'll need to create another variable in order to hold this result. So let's go give that a try. So instead of this, we're going to create a new variable, an integer variable, comparison result. And we'll start that with a 0. And then we'll do comparison result equals string 1 dot compare to string 2. So there's our comparison. So we're going to get a value back out of that. Don't know what it's going to be yet, but let's print it out and find out. It's always good to print out things as you're coding and testing to make sure you're getting the values you're expecting before you write lots and lots of code. We'll come back to the if statement after we get this value and see what we have. And we'll just do a standard print. And temporarily, I'm going to comment out this if statement because it's not going to work the way we want to anyway right now. Let's get that out of the way. And we'll give it a run. And it did not like that either. So let's see why. Oh, I see. I put the comment in the wrong spot. Okay, let's try that again. And I made a typo in the variable name. And we'll try one more time. And the result is minus 14. Okay, well, it is a negative number. I don't know why it's minus 14, and I don't much care. I just know that it's negative, and I know apples is less than oranges. If I made string 1 something else, let's make it, I don't know, zebras. I can't spell zebras, apparently. Zebras. And run it, I would expect a positive number. And I do. I got an 11. Okay, great. And if I make them both oranges, I will get 0. There it is. So now we can build an if statement that will have to capture all 3 values, or optionally we could use a case statement, a switch statement, and break up the different cases of which way we want to go. I'll leave that up to you to decide. I'm going to go with an if statement, just so we get some practice with the if statement. So if comparison result, you know what, I'm just going to copy that, paste it, less than 0. Then we'll print out string 1. Else, if comparison result, I said I was going to paste that, is greater than 0, I'll print string 2. Else, well, there's no other choice. It's either less than 0, greater than 0, or equal to 0. So we'll just print out the same. And I forgot a capital S over here. So let's run that. Result is 0. They're the same. Let's try apples again. Apples, great. Let's try zebras again. Very good. So we have our little logic here. I'll put apples back. So we can use the compare to operator to determine if strings are bigger or greater than or less than each other. The next thing we want to take a look at is string equality. So we can't even just compare 2 strings with the equal operator. The reason is because objects are stored in memory, and it's a pointer from the object's variable name to the memory location where the data is stored. So without getting into all the details of objects and memory locations at this point, every object is going to be stored in its own different location, so everyone's going to have its own memory location, and they're all going to be different. So we need to use string methods again to compare 2 objects for equality. Now, we certainly can use the compare to. That does work if we know we want to check it to be 0, but there are others. And fortunately, it's an even easier method to remember. It's called equals. So we'll keep this code, and we'll write another statement, if. And now we can actually put the string directly in here. String 1 dot equals string 2. And we can put a print statement, same string. Don't need that black line. And then we'll do else. Then we'll just do a print statement to tell that the strings are different. Okay, so looking at our data, we see that we have apples and oranges. I would expect, based on this output, I would expect to see the negative and string 1 printed, and then I would expect it to say different strings. Let's test it out and see what we got. Yes, perfect. If we try zebras, I would expect it to say the result is some positive number, expect it to say zebras, and I would expect it to say different strings. And it printed oranges. Why did it print oranges? Oh, because it's doing the comparison. That's right. So it's going to print the oranges of which one came first, because that's what we were looking for. And lastly, if they're the same, and there we go. Same, same, same. So that's how you compare strings. So something else to think about here is if we had one string called oranges with a capital O and one with a lowercase o, are they the same? Well, the answer is no, they're not. They're different because they have different letters. Even though they're essentially the same thing from our point of view, from a person's point of view, from a computer's point of view, no, they are very different. So there are alternate methods that we can use to ignore the case when you're doing these comparisons. And the simple change is to, instead of doing compare to, you do compare to, ignore case. There's more methods that have the ignore case that will do the comparison. Now they're the same. And if I do it down here, ignore case. If I run that there also, you'll see we'll get the same again. Except I can't spell ignore. Let me fix that. And there we go. So you can ignore the case if you want to or not. All depends on what your application is and what you're trying to solve. Okay, so let's save this piece of code, and then we will look at some other string operations that may come in handy, not only for this week and the labs, but probably for the rest of the semester. Okay, so let's clear all this out except for the strings. We'll keep that. We'll need those. We'll at least need one of them. I don't think we'll need two. But here's our string, and we're going to change it. Let's see. The quick brown fox jumped over the lazy sleeping dog. Famous sentence that I learned in typing class many years ago that uses every letter of the keyboard, every letter of the alphabet in one sentence. So it's good for testing different things, and we're gonna tinker around with that now. So if you think of a string as a list of characters, and we know lists start at 0, we start counting at 0 in Java, we can think about the order of the letters. So the capital T would be position 0, the H would be position 1, the E would be position 2, and so on and so forth. So if we wanted to print out or access a single letter in this sentence or this string, there's a method that we can use. And we kind of looked at it a little bit already with the scanner when we wanted to read a single character. It's the caret method. It's the same method name. It will give us one character at the position we specify. So let's just do some prints and see what we get for comparison for results. If I put down string 1 dot char at and I pick position 0, I'm expecting a T to print. And we'll run that and see. Yes. Now, if I wanted to pick a different letter, string 1 dot char at, let's pick position 10. Let's see what's that position, the 11th position of the string. And if we do a quick count, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like a B. and we'll run it. And there's the B. So we can print and access the different characters of a string, individual characters. A couple of things to note. If we pick a negative number, let's see what that does. Yeah, it does not like that. So there are no negative indexing, so you can't go out of bounds. Again, here's your index out of bounds error. We can see the total length of the string is 53, and index is -1. So remember, we start from 0, we go up to 53 characters. -1 is not in that range. We get the out of bounds error. Similarly, if we put in 53, we get the same error. 53 is out of bounds because the length is 53. Now that seems counterintuitive, but if you remember, if you start at 0 and you count 53 characters, you end at 52, not 53. So 52, if I put in here, oops, I would expect to see the G print for dog, and there it is. So whenever you're accessing and get an error like that, check your array indexes, your char@at indexes to make sure you have the right value. This is the index value you're looking for. Make sure it's in the range of whatever the string is. So you may be saying, well, I don't know how long the string is. Well, there's a method for that. We can look at string1.length, and that will give us the length of the string, 53. So now we have a way to get the length of the string. Now, why is that important? Well, if you think back to the for loop, when we want to have a starting and ending point, if we had the starting point of 0 and the ending point as this length of the string, we can now access every character in that string sequentially. So let's try it. For int I equals 0. And I should also note that the textbook does not like it when you do int I equals 0. They prefer declaring the int values separately. More of a personal preference. I don't mind it. If you want to do it that way, that's great. If you want to do it outside of the for loop, that's fine too. We can do I less than string1.length and I++. You're almost always going to see I++. And if we do a system.out.println, and now we can combine the character at methods with this length method that we're using and be able to print each character in the string. So we can print out string1.char at and I. Not an actual number. We're going to use I this time, which is the index value, into our string. And just for now, I'm going to comment out these lines of code so we don't have extra lines that we don't need. And this time I'm just using the single line comment. And we run. And if you scroll back in the history, you could see every character being printed one at a time. So you have the ability to get the length of a string. You're able to access each position in the string. So similar to the math library that we looked at earlier, the strings method or strings class has a slew of different methods that are available to you to solve different problems in different ways, give you different results and different operations. Over here, I've got a list from, again, W3 Schools, another great resource, with a whole list of all the different things you could do to strings. Take a look at it, get a feel for what they are. You may want to use one or more of these in some of the labs or assignments going forward, and just knowing what's available to you to solve a problem may change the way you think about attacking the problem. So yeah, just take a look, get used to it, get familiar with where it is, and what might be available for you to solve some of these lab problems. Okay, so jumping back over into our book, we could see we have the compare to, we have the character at. So yes, definitely take a look at those, give it a try. Next, and the second and final topic for today in this video, I wanted to talk about something called variable scope. So up until now, we used a variable throughout the entire program. And that is not always the case when we are working in a programming language. Sometimes variables live only, or when I say live, they have their existence valid only in certain blocks of code, certain areas of code. In this particular lab, and we'll keep working in this lab, the string1 variable is valid throughout the entire program because it lives or exists in the curly brackets in this main method. So it is valid from this curly bracket all the way down to its ending curly bracket. It can only be referenced there. Now, if we had created a variable inside a loop, and we'll take a look at that in a second, it may only live inside that loop. So let's modify this program slightly, and we'll define a variable inside the loop, call it current character, and we'll assign it the value of string1.char at I. And my typing stopped. There it goes. That was weird. Okay. And instead of printing this value, we'll print out the variable. Now let's just run it, confirm that it still works the same as it did before, and it does. But now I decide I want to print out, for whatever reason, the last character was, and I want to print out whatever that last value of current char was, because that will contain the last value in the string before we exited the loop. And when I run this, I would expect a G, but I don't get a G. I get an error, and the error says cannot find symbol. So the error is telling us that the symbol, in this case current character, the symbol is a variable, it cannot be found. And the reason why is because that variable does not have the scope of the main program. That variable only is in the scope of the for loop inside these curly braces. So you cannot reference this character, this variable, outside of the curly brackets where it was defined, outside of this loop. If I had taken this code here, and instead I put it in here, well, I think you could see it's going to do the same exact thing because it's almost identical to the print statement above it. So I'm not going to do that and run it. That's just a waste of time. So you could see that as you create variables inside of blocks of code, such as this for loop, you may not be able to access them outside the for loop. In fact, you cannot access them outside the for loop. You can access the other way, meaning the string character, for example, is not defined inside the for loop. It is defined outside the for loop, so you can access it. So you can only access things that are in your scope or above. You cannot access things that are outside your scope. So you cannot access current char outside the loop, but you can access string1 inside the loop. So that's the basic premise of local variables. So keep that in mind if you see something that says cannot find symbol. You could get that. That's most likely what it's referring to. A variable with a name that's either been mistyped or the scope is not valid. Okay, so I think that wraps up today's session. That should give you a little more of what you need to help work on these labs. I will do a practice lab next in a couple of days and post that video for you so we could work through one of these looping exercises, and I'll show you how I solve it, and hopefully that'll give you some insights on how you can solve yours. Anyway, that's it for today. Have a good day. If you have any questions, feel free to reach out, and I'll see you next time.